Boa noite. Primeiramente, mais uma vez, muito obrigado pela presença de cada uma das pessoas que estiveram aqui para participar com a gente. Esse evento, a gente, como havia comunicado, ele será em inglês, por conta de um participante, um painelista que será internacional, né? Para informar a todos, infelizmente, a princípio, o José Carlos Bruno não vai conseguir participar desse evento, ele estava previsto desde o início, mas por conta de um chamado do trabalho, ele infelizmente não conseguirá participar. So, just informing the international audience, so José Carlos Bruno won't participate in this event due to work exception. So, I'm so sorry about this, but we will hold a really good event. Falando rapidamente sobre algumas entregas para o público brasileiro, a gente vai ter o Student Paper Contest de 18 a 22 de outubro. Para maiores informações e submeter o paper, etc., por favor, visitem o site da SPE Brasil Section. Outro evento muito importante que a gente vai ter em outubro, o Seminário de Descarbonização no EIP, também de 18 a 22 de outubro. Ele vai ser realizado pelo nosso Comitê Técnico de Sustentabilidade. Nós somos parceiros da Abrisco no Congresso Abrisco 2021, que será realizado de 22 a 24 de novembro, e a chamada para trabalhos é direto no site da Abrisco, mas era até dia 30 de julho. Né? A princípio, a Abrisco não está mais aceitando os trabalhos para serem apresentados no Congresso. Bom, Tech Tuesday, toda terça-feira, a gente tem pela SPE Brasil a terça técnica, e a agenda das próximas 2 semanas é sobre elevação e escoamento e também sobre análise quantitativa de riscos em poços de petróleo. Parceria SPE Brasil, a gente tem uma parceria com a TN Petróleo para que as pessoas enviem para a gente alguns artigos técnicos para que sejam publicados, né, na TN Petróleo e serão avaliados pelos comitês técnicos da SPE Seção Brasil. E, obviamente, receberão um selo de peer review garantindo a qualidade técnica para a indústria de IP daquele determinado artigo. Ok. HSE Talks, nós temos a agenda prevista do HSE Talks. Dia 27 de outubro, teremos os eventos sobre segurança operacional no handover de Campos Maduros. E no dia 24/11, que também é a última quarta-feira do mês, mantendo a tradição, incorporação das lições aprendidas no sistema de gestão e segurança operacional. Todos no mesmo canal da SPE Brasil Section aqui no YouTube. HSE and BRC Congress, por favor, reservem a data. De 9 a 18 de novembro, a gente vai realizar o primeiro congresso online de HSE da Seção Brasil. Tem uma série de oportunidades de aprendizado. Quem tiver mais interesse em mais informações, a gente vai publicando. A gente tem publicado, aliás, muita coisa no LinkedIn da SPE Seção Brasil. Então, por favor, sigam o LinkedIn, o Instagram e o YouTube da Seção Brasil. Bom, so now I will change for English. So our event today will be held in English due to our panelists from other countries, so from Mexico and from USA. So I really want to make some special thanks for people who supported us until we arrive editions of HSE Talks and completing 1 year of this huge event. So that really shared a lot of knowledge with our industry of petroleum and gas, oil and gas industry. So my special thanks to Paula Garcia, João Pedro Esteves, behind the screens here. So Lara Maciel, Larissa Maciel, so people that I have the honor to lead to the success of this event. So we reached 1 year of success due to the hard work of this excellent team. So you are incredible people. So next steps. So other special thanks for João Rodrigues, a person that I have the honor to call like my old brother sometimes my daddy, sometimes my boss, sometimes my my little brother. So, but always the best friend that I always have had. So, Johnny, you are awesome. You are incredible. So now today exists an professional so named Itamar Junior. So I am a great engineer due to all the things that I known to you. So that I learned to you, so with you. So sorry. So Ivan Lima, my mentor too, with João Rodrigues. So he's kind, a brother too. So I learned a lot with him. So and he's behind the screens too. So is my partner in the SP Brazil section directory. So and with Pedroso too. So and Pedroso, so our lead, our president. So thanks for allowance for the allowance to the HSC talks being these huge events. So thank you all. Now I invite João Rodrigues. João, the screen is yours. Thanks for all, and give us some great words as you ever do. Thanks.
Not too much to say after your words, but let me try something. We need to start saying that it's really great to see you all there, and mainly our lecturers in this evening. The people who will be here to tell us something about human factors are really great professionals, and you will see that. You always will see that. Human factors scope has actually been a key area to all of us in our safety community since 80s and 90s, when this discipline started being discussed and more deeply studied more recently, I would say. But since we started knowing that all technologies to ensure our safety, to ensure higher productions and so on, but behind all of these new setups, new technologies, the human being is always behind that. So since we started noticing that, human factors started having the real relevance that it deserves. So we are here to discuss that. And this importance is seen once we notice the heavyweight people that attends to our human factors forums in SP International. Some of the most skilled people dealing with human factors can be met regularly in monthly meetings in our SP International. But now in Brazil, in our Brazilian section, we started having the opportunity of learning a lot with persons like you are going to see now here. And it's quite good for us. Pedroso will give us some lights about the current work in SP Brazil section and show the guidelines for this event, which is one of the best in our career of 1 year career that we are doing here. But I would like to add some words of respect and thanks to Itamar, who had not just by his birthday today, but also by the great work he has been doing to keep our HSE department moving ahead, mainly in this pace we have been running. But also to Itamar, Ivan, a real partner in too many situations along our life, our professional life, to João Pedro, to Lara and Larissa, two young sisters, but extremely high potential petroleum engineers in the short term. We must always say thanks as usual to you for moving our discipline ahead. And hopefully we will be together in much more events like this and in our meetings, monthly meetings in our safety committee. So Pedroso, please be welcome and open the doors for all colleagues there. Yeah.
Okay. Thank you for the words, João and Itamar. Happy birthday, Itamar. It was a great pleasure to be here celebrating these two big events, your birthday and the 10th HSE Talks, 1 year of success of this really big and interesting event that has been organizing by the HSE committee, one of the committees, but for sure the most active in the Brazil section. So I would like to welcome everybody. Good evening, maybe, and I hope good morning and good afternoon for the people around the world that is seeing us now. And I would like to invite all the audience to learn about this topic. This topic was chosen very carefully because it's really a very important and hot topic for the industry. And that's the reason why it was chosen for this 10th HSE and for the 1 year of success of this event that, as Itamar told us, was every last Wednesday as part of the events of the SPE. And I invite everybody to follow us every Tuesday. We have the SPE Brazil Tech Tuesday, the events from the committees that has been organized by Ivan, as Itamar told us. We have the Sustainability and Energetic Transition Committee, the HSE, this committee, the Digital Transformation Committee, and the Flow Assurance Committee already installed and making a lot of events. I would like to invite you to do that. And about João told us about the importance of this event, the human factors, that is, as I told you, a very hot topic. And we have a real constellation of people to talk about that. Unfortunately, José Carlos Bruno, that is a distinguished lecturer today, talking about this topic, won't be with us due to a work situation, but we will have Josué Maia, that is a very skilled professional talking about this topic also. He made a very good presentation here. I invited him to be to apply to be a distinguished lecturer. I hope we have another one. Also, Hector Guzman, Caroline Moraes, that has also participated in our events, Felipe Gastaldo, and Marília Ramos. All will be presented by Josué. So let's start. I would like to pass the word to Josué, which will conduct this webinar. Josué, the screen is yours. Thank you.
Thank you. Thank you. Well, here I feel that we are in a very special place, because we have scientists, we have professors, we have doctors that are going to bring a special view and special knowledge regarding human factors and human reliability based on regulators, academia, and business. Well, with no further delays, I would like to introduce you Marília, our first speaker today.
Thank you, Josué. I guess this is just a mini bio moment, right?
Exactly.
Thank you. So good morning, good evening, good afternoon for those who are watching us. And I would like to start by thanking SFP Brazil for the invitation. It's very glad to be here and sharing this panel with all of these great experts. So just very quickly, I am Aurelia Ramos. I am a research scientist at the B. John Garrick Institute for the Sciences at the University of California, Los Angeles, UCLA. I have been working with human reliability analysis for 9 years now. I am a chemical engineer, and my PhD was on actually human reliability analysis methods for the oil and gas industry. I did a postdoc in Norway at the Norwegian University of Science and Technology at NTNU, when I started working with autonomous systems also. And today at UCLA, I work with human system interaction and human error in a diversity of industries, including oil and gas, but also nuclear and autonomous systems.
Could you start your presentation now and bring us with these your great ideas that you have already in mind?
Yes, I can. Let me share my screen. Okay, so we have this one slide, 5 minutes, very quick presentation, which was a challenge.
Of course.
And I would like to start with what is human reliability analysis? What is HRA? And let's start just saying HRA from now on because it's easier and shorter. So on HRA, we analyze what can go wrong, how can the operators make an error during that operation, and why would the operators make those errors? So basically, we are modeling the human system interaction in a diversity of operations. So imagine operators working in a control room and supervising a production unit. What can go wrong in these interactions? Which type of errors can the operators do? And when we talk about errors here, we are talking about what is expected from the operators to keep the plant safe or to bring it back to a safe status. And then from there, we start analyzing, okay, why would they make those errors? And these are what we call the performance influencing factors. So all of these factors that influence the probability of a human error, the quality of the procedures, the stress, the time available to do this operation, the quality of the human system interface. We analyze all that and we normally quantify it. So we quantify the probability of the human error. It is also possible to have HRA methods that are only qualitative. So I don't want to put it out there, but we normally quantify. So our main goal is finding out the human error probability. And with these analyses, we can derive risk reduction recommendations. So which errors lead to the higher consequences, or which error are the most probable ones? So considering probability and consequences, we can derive risk reduction recommendations. There are many HRA methods, and they were mainly developed or tested or applied in the nuclear industry context. So the nuclear industry is a leader in a way of using and applying and developing human reliability analysis methods. In the oil and gas industry, what is typically done is, as also in other industry, is adapting existing methods for the reality of the oil and gas industry. So imagine translating the factors that make sense in the nuclear industry to those that make sense in the oil and gas industry, in the interaction, but also in these performance influencing factors. And what I would like to pinpoint about that is that the nuclear industry has a huge history of applying HRA methods. And the state-of-the-art discussions on HRA that are led by the nuclear industry community nowadays must be considered when we define a technical roadmap for a credible HRA method for the oil and gas industry. So that means that the method chosen to be adapted for the oil and gas industry should not only be adaptable, that means it can be translated to the oil and gas industry and our type of operation, but it should also take into account the state-of-the-art discussions, and those include points such as the increasing understanding of human behavior and the inclusion of cognitive sciences, initiatives for HRA data collection and thus HRA methods that can take as input also this data that is collected, robust quantification methods such as Bayesian belief networks, and the use of software for complex analysis. Since we all have access to powerful software and hardware, we don't need to go paper-based anymore. And some methods were developed in a way that would be easy to apply when we could only go paper-based. So this is my 5 minutes, one slide on HRA and some specific point on HRA for the oil and gas industry, talking about HRA methods. Thank you, Jose.
Thank you, Marilia. It was fantastic. And I think that we are going to have a very great discussion a few moments later. And another international presentation today after Marilia from United States now is Hector from Mexico.
Thank you, Jose. Allow me to introduce myself. My name is Hector Guzman. I am an HSE professional. I'm a certified safety professional in the US. I'm also a member of the American Society of Safety Professionals for the Mexican chapter. Been working in safety and HSE for about 32 years of my life. Sounds easy. Not too much. At this time, I'm working for a medical industry. In my experience, I have been working a few years with the oil and gas industry, with electronics, manufacturing, construction, a wide variety of certain processes around the world, actually, including Latin America, South America, some places in Europe and Asia. I have also a slide to share with you. Let me see. I think it's going right. So
no, I'm not seeing. Could you double check, please?
Should be there.
Oh, fantastic. Fantastic. It's working.
So these are my key points for today's discussion. It's based on my experience in a wide broad of industries, not just oil and gas, right? So very interesting because Marilia was talking about the error, and something that we need to remember and we need to take into presence is our employees do and will make mistakes all the time. People are fallible. Even our best employees will make mistakes at the job. So we need to be aware of that when we design our processes, right? Sometimes when we design our processes, we deploy and implement a lot of rules, a lot of procedures, a lot of ways to do things. And what are the employees' feedback on that? Those rules, those procedures are very easy to follow when they are easy to follow. When we deploy complex procedures and complex rules, they are very difficult to follow, and sometimes they are not. So our employees adjust the process, adjust their procedures. Sometimes they drift from the procedures in order to get the job done. Basically, our employees try to do the job the best way possible. But also take me to the third bullet point. The human factor is always the most complex variable in any safety equation. In any process that we try to deploy safety in it, the human factor will be the most complicated of all, right? So our challenge as safety professionals or our industry professionals or our engineers, either in the oil and gas industry or in the nuclear or any industry we are, is creating the work system that can tolerate human factor as part of the equation and be successful. That means how robust is the process to resist the impact of a human error and don't have a catastrophic event. That will be the interesting thing, and that will be my 2 cents into the discussion that we will have today. Josue, thank you.
Thank you. actor. Fantastic. Always showing the complexity in a simple way. Fantastic.
Right.
And bringing some complementary perspective. I would like to introduce you now, Felipe. Please, Felipe, go ahead.
Hello, everyone. Good evening, good morning, good afternoon. Thanks so much to be here today. It's a pleasure to me to join the colleagues and also the audience and talk about this very excited topic. As Josué said, my name is Felipe. I am a mechanical engineer who have been working in the oil industry since 2010. In this journey so far, I could work in different functions, from operations to HSNE, working in Brazil, Mexico, and also Mozambique. Most recently, I joined RZX, a startup company where we are transforming the way that we that the key industry combats the human error. So I'm very excited with this conversation today, and yeah, all the best for us. Let me now change it to presentations.
Please.
Okay, should work.
Perfect.
Is it working? Okay. So
yep, for sure.
Today I will bring you a small portion about cognitive systems engineer. In this topic, and we will call it CSE, it's more important to understand what a cognitive system does and why it does, rather than to explain how it does. According Honagle and Wood, which is the actors from the picture that we can see on the middle of the screen, it's a very important premise for the CSE is that all work is cognitive. CSE consider only the use of artifacts without making distinction between cognitive tools and non-cognitive tools. In this, in the CSE perspective, by doing work, humans and technologies form this cognitive system. Another important note here is to bring the distinction between body and working with the body and work with the mind, between doing and thinking. Currently, situations is one of the very little manual work and more cognitive work. Let's bring it to our reality. Remember how many people was needed to drill a well back 80s or even before? And where we are today, we are reaching the autonomous drilling at some point. The aim here is not to give you a lecture about cognitive systems, but bring some concepts, associations, and analogies. So let's start talking about a very known situation, which is drive a car. Ergonomics and human factors have traditionally focused on the interaction between the driver and the car, such as how the instruments should look like, how the controls should look like, and or be designed, and so on and so forth. All this looking at how competing interest for the driver's attention can affect driving. All this together all this together is the car driver system. Now we systematically will add pieces to our system. And following the pictures on the screen, the next one is the roads or the environment. Bringing it to our system, we will move, focus on only a car and a driver, to a plural way: cars, drivers, and roads. And it will be our new joint cognitive system. Keep doing this. The other piece is the infrastructure, right? Infrastructures can also be related to road signals, road marks, and road preservation. And now we will have an even bigger cognitive system: car, driver, roads, and traffic. The next one is topography. Then driving a car in a mountain or on a plateau is totally different, right? So if it's different, it also matters. And finally, the weather. Weather can also add another part or piece in our performance while driving. So it will be together on our very, very now big cognitive system. Since all these pieces influence our performance, they're all together, and maintain control of the work. And to maintain the control of the work, we can suggest two perspectives. One is how to make the work easy, and in the sense of making it easy to maintain the control. And the other one is to make the work safe, in the sense of minimizing the possibilities of unwanted outcomes. To try to facilitate the work, we can consider in a very high level way: good interface design, simplicity of functioning, clear indicate system operational state, and also clear and precise instructions. Knowing that, I will anticipate and bring a question to you. How do you think that all these systems could be developed? Cognitive engineer is a multidisciplinary field of research, combining human and technology elements. One approach is to respect the human and understand that human fluctuates in terms of his or her cognitive abilities, not only on the daily basis, but also during the day. So, to build the systems that are resilient, we also need to understand interactions between human and the joint cognitive systems. Finally, one way to do this is to deep understand what matters and helps the humans' interactions with systems. Also, know what are the noises that might have negative influence. Techniques such as electroencephalogram and eye tracker have been used successfully to map the real influence of all these on the human brain. Sorry. While they are in the human brain, while they are performing the tasks. Combining this understanding of the cognitive side and also the cognitive system, we can or we might achieve an even more safe workplace. So I'm very excited to see some questions with the audience and also with the team, and I will pass back to Josué now. Thank you.
Thank you, Felipe. I really enjoy your slides, especially because there is Professor Eric Hohnagel there. And closing this part and doing a bridge between human reliability and human factors, I would like to ask Caroline to come here, our doctor, and I believe one of the most brilliant figures of the oil and gas industry in this area, human factors and human reliability. Caroline, go ahead.
Thank you, Josué. It's kind from you. Well, I'm Caroline Moraes. I'm first of all a technical from Rio de Janeiro, technical, and then after that, a chemical engineer. And then I have a master's also in process, and now a PhD in human reliability analysis. One of my goals with the PhD was to understand better how we can regulate the oil and gas industry, how we can enforce the human factors practice, not only in operation, but also in design. That's me. Now I'll pass to the presentation.
Yes, please.
Share the screen.
Share the screen, the presentation, your thoughts for us.
Can you see my screen?
Nope.
No.
Yep. No worries. We'll find a way.
Can you see now?
Still don't. Sorry.
Oh, okay. I think it's working now, right?
Fantastic.
Okay.
Now we got it.
There's a problem of human-machine interface here.
Oops.
Okay. Well, I'll try to talk very quickly in a challenge about the 5 minutes challenge about how we as regulators see each of those terms. So first of all, the human errors, we are not seeing that as a judgment. We are seeing that as a science. So we are not going to talk about human performance only. We have to talk about human errors because we are talking about our bodies, hormones and brains and cognitive limitations. And we are talk about when, as Marilia said, when you are going to talk about risk reduction, we have to know the remedy to each human error. For example, if you do a mistake, probably you have to improve your procedure. But if the type of human error is a lapse, probably you have to improve the science next to the equipment. And as a regulator, we need to know how organizations are going to improve their projects and processes to respect the human's limitations. So we have to understand the science of human errors, okay, as a science. Human factors, so we know that it's a kind of a collection of good practices. It's a very broad topic. And we have books. There is a book that is coming this October, I think, from CCPS, Human Factors book. And they are going to tell some procedures like permit to work can't be, we have to avoid the permit to work by night, for example. So it's a collection of good practices that industry are trying to input during the operational phase. But it's also a science that comprise ergonomics, psychology, sociology, and so on. Many researchers in human factors, they are trying to correlate some organizational factors and technological factors to the human errors. For example, like Felipe said, we have eye tracking, experiments of eye tracking versus fatigue, or tracking brain signals versus complex tasks and lights, and trying to investigate how long does it take an operation. So there is a very broad topic, human factors. But the most importantly, human error science and human factors science are the base for human factors engineering and human reliability analysis that I'm going to talk now. So human factors engineering, it's a kind of a compilation of good practices. So everything that has to do about a control room, the number of alarms in the control room, the positioning of a valve in a platform, oil and gas platform, you will have a good practice from industry. And you can see lots of them in these reports right here. Report 454 made by Energy Institute and IOGP. It's a very good one. It's for free. Itamar is going to drop the link for you there. Already shaped to oil and gas industry. And these human factors engineering, they also are linked to human reliability analysis. So even if you if you applied all the good practices of human factors in your project, in your design, you also have to see the risks. It's the same as seeing component reliability. You have to see the human reliability as well to know the frequency or the probability of those risks, okay? So this, on the right, you're going to see a publication is free as well. So it's a review of human reliability assessment methods up to 2009. Of course, we have more. We have from, that Josué is going to talk later. We have one technique that Marilia uses to use in her research. So, but this one was the shot of that moment with the valid analysis. Well, so this is a model that the human reliability assessment methods, they are kind of a model of how organization factors, technological factors, and individual factors as well, they trigger human errors. So you're going to see systematically how each of them are going to trigger error. And you're going to, as Marilia already brilliantly said, you're going to see the ones that are most important in your project, and you're going to choose them to reduce the risk. So please feel free to access those links. They're really interesting. And finally, safety critical task analysis is part of the qualitative aspect of the human reliability assessment methods. The most used is the hierarchical task analysis, that you break your written procedure in some blocks. But most importantly is that as a regulator, you really wanted to know how what's the methods that the industry tracks, like time to finish a procedure or the workload of the team. So there are some safety critical task analysis named workload task analysis, that you can see the size of your team. So during COVID situation or during another types of downsizing, that you have to see if the size of your team matches the complexity of your project. It's very important to have a safety critical task analysis, and also the timeline analysis. So you drop a hardware and you want to see if you're going to have your operator is going to have time to go from the control room operator to the plant to do that operation. So you have methods to do that. It's not just by experience, you have methods. And just to finish, the human reliability analysis is very important for us, not because it's auditable, but because you can prove when you have a doubt about a recommendation, for example, in a risk analysis, you can use human reliability analysis to show to your boss that maybe you can drop a hardware recommendation, a hardware barrier for a procedure made by humans, and you can show that that doesn't pass the safety levels, the risk levels. So it's very important, and we can discuss further. Thank you, Josué.
Thank you, Caroline. Well, seeing your slide, I can see all the coincidence and convergence that we have on human factors and human reliability. Of course, we have difference, but I think that's the best option is focus on the coincidence and convergences. And right now would be our friend Bruno. Unfortunately, he can't do his presentation now, but I will try, how can I say, to put some seasoning on my presentation from his perspective, which one I agree very much. He's how can I say, a hands-on human factor practice. So I really enjoy his method. Well, presenting myself, my name is Josué. I'm professor, engineer, and postdoc. I had some works also in neuroscience. I work currently in Petrobras, and I'm a professor of some institutions in Brazil and abroad, especially in Sweden. I would like to share with you some thoughts and a presentation that is already set here. Let's see if the human interface works fine today here. And my idea here, guys, is to show you something that is very normal in our day. As Bruno used to say, people do normal thing in normal job in normal days, and suddenly an accident happens. Well, if you just stop for a second and see a mug, a plate or something, washing the dishes. When you are washing the dishes, you may have this same process that we have here. You have a pressures of times, you have a manager, in my case is my wife, she's the manager of all. You have the engineering process, we have the different ways of washing different dishes. If you stop for a moment, you're going to see a lot of coincidence in our daily basis routine and our jobs. But something that I would like to highlight for you, we must evolve. We must go from what we do now and go further to a new view of how doing things, whatever you are, whatever you do. My idea with this presentation and is show to you that sometimes we are so concerned to do a safety work, to follow the safety rules, to do a safety stuff, to obey a safety stuff, something that we forget about doing things safely. It's very important, and it's the main concern of what we talk the safety tool perspective. And as a good engineer, I would like to show some numbers, because sometimes people say, Josue, sometimes this human factors theory doesn't match my expectations because I don't see the numbers. Well, let's see a few numbers. There is 357 different procedures for engine failures in airplane, and 2 professions, a pilot and a co-pilot, saved 155 people doing things safely. And you may say, oh, everyone knows about the Hudson. It was once in a time. Well, talking about once in a time, recently in 2021, a ship, an evergreen ship, has crossed and blocked the Suez Canal. And everyone got attention on that. Oh, it was a human failure. It was a human error. The problem was them. Okay, do you have an idea how many ships pass daily in Suez Canal? It's about from 40 to 100. The maximum is 106. But the average is 50. If you could do a very quickly mathematics, you're going to see that 20,000 ships cross a year the Suez Canal. So in about the 1999 other times that everything goes all right, the human performance did well, doing some adaptations, variabilities, as Professor Honaigo would say. Well, have you seen this part? Have you learned from that? I know very clearly we can learn from mistakes, but in about the 99% that of things going all right that we could learn as well. And ending my part here, the Suez Canal has just closed 5 times, and just one of them was, how can I say, attributed to human error. So since 1969, it's working perfectly thanks to workers, Indians, British, French, and a lot of different countries with different cultures and different ways to do things. So I would like to ask you and invite you, let's learn about this. Let's learn about how to do things safely, not only follow the safety things and do the safety thing, but really internship the safety stuff and doing things safely, just like that. And with this, I finish my presentation here. but not my participation. I'd like to ask my colleagues here, the other speaks, so we can have some ideas, some thoughts, and discuss even further. I have included here some good questions from the audience. What do you think, guys? Let's answer some. What do you think?
Yeah.
What do you think, Marilia? Should we
Yeah,
answer?
absolutely.
Oh, fantastic. Oh, I have one here. I believe it's from João Pedro Esteves. Human error is normal as zero accident is a goal, but can be 100% achieved. Can or cannot? How do you work around the culpability of commit an error? Well, I can't understand 100% the question itself, but let's start this way. What do you think, my colleagues here, about having zero goals of accident? Maybe you can start with the ladies because here we are gentlemen.
May I start actually with the last part of the question,
Okay.
which is how do we work around the culpability of committing an error? One of the reasons why human reliability analysis as a science, as an approach, as a methodology, and as a discipline has been developed, even evolved, is the understanding that we all perform our actions and decisions in a context, and this context affects the humans, and that's what I was talking about, the performance influencing factors. And you see a huge increase after the 3 Mile Island accident, which was a huge accident on a nuclear power plant here in the US. And they realized that there was human error involved, and the way to deal with that human error is not by replacing that human, because if you replace a human and the context does not change, actually it's not the culpability of that person if the person that replaces them will commit the same error. So when we model human error, that's why we go into the performance influencing factors, and that's why they are so important, because we go into, it's not about the culpability, it is about how to make that person have a less probability to make an error or a mistake. The probability is never zero, but it can be very, very low if the conditions allow so. So we have internal factors and we have external factors and we have organizational factors, as Caroline was explaining. So that's how I would respond to the second part. How do we work around the culpability of committing an error? We don't go through that. We don't go through culpability, and going through culpability is a bad organizational structure and a bad leadership.
Well, I couldn't agree more, including I think that there is a small plate from the audience about your grade. You got a 10 in your answer. Fantastic. And Felipe, could you say something about the contest? I saw that your presentation was very useful, showing that graphics, that the weather in the contest of driving a car is important. Could you complement her answer with that, please?
Yeah, I can bring in here, keeping with the driving car and driver example, and adding pieces to these systems, and complement, saying that imagine if a person is driving the car, need to go somewhere, and you actually don't know exactly where to turn right, to turn left on that road or that street. So nowadays we will go to GPS, Waze, or whatever system we can use, right? So the idea behind here is to have systems like a GPS, for example, to try to support us on that. So we will have the conditions of the road plus the sinuosity of the road, of the street, plus the weather. So, and we don't know exactly how or where to turn left or turn right, or it can change, because we can, okay, I know the way to go to that specific place, but when you reach there, the road is blocked, then you need to take another road. So I mean, this is the common life. I mean, driving or working or washing the dishes. So, for example, having the GPS or having a system to support you and give you feedbacks about what to do if something is not going wrong, right? And also if you are speeding up, okay, man, go slow. So having this type of systems is one way, right, to support people and avoid these errors during the journey. So yeah, this is something, and also to finalize, people are not always the same, right? So at that particular day, we are in a new road, raining a lot, and we are, I don't know, maybe thinking about our, I don't know, mother or child that is sick. So I mean, this is the daily basis. We need some support to better achieve our outcomes and also to make less mistakes.
Fantastic. And getting what you said regarding all the system, I think it's differ from culture to culture, use or not the GPS. When I start to drive, I use a Guia Hex, something that I think there isn't anymore. So now there is GPS. And it brings the first idea that Marita said about organizational factors. And I think we have here someone that knows how different cultures can affect safety, because at least United States and Mexico, he knows a lot. So Hector, could you say something about, in your idea, how organizational factors can affect human performance, and answer the question, could go or not go for an accident?
Absolutely. I was listening to your answers, very, very constructive answers. Yeah, I totally agree that context drives behavior. Context impacts behavior, absolutely. And taking your example, Felipe, on the driver, on the driving, I don't drive the same when I'm in a road with snow than when I'm in a dry road. I don't behave the same when I'm driving that I know I'm going to vacations. I'm going on vacations, I'm going to the beach, I'm going with my daughters in the back screaming and everything. That context is different than when I'm driving to the airport because it's getting late or I'm going to lose my flight, right? So that context impacts absolutely the possibility of either I'm making an error or not, right? So absolutely, context drive behavior. On the part of the zero accidents as a goal, new organizations are going from the zero injuries, zero accidents goal to how strong are the line of defenses, how strong are the defenses of the process to cushion or to hold that accident to go further or to become catastrophic failure, right? So how strong are my defenses, my guards, my processes to avoid the error? The error, as I say at the beginning, errors will happen. Let's be aware of that. Errors will happen all the time. So how strong is our process? Has our process been developed in order to cope with those errors when they happen, right? So that's what will give us I'm quoting Dr. Todd Conklin in this case. He says that safety is not absence of accidents, but how strong are the defenses of the system, right?
Fantastic, Hector. And your you quote Todd Conklin, and would like to quote Jean-Christophe Lecause. Last week we were in the Safety 2 International Workshop of 2021, and he said something like that. I like it too much. As much as part of a measure or control behavior, we should have our lenses and understand it on the context, because once we know the context, we know what is happening and know what is happening, we can have not strong defense, as you said, but he said something like dynamic defenses, dynamic responses for the system, and have a resilience of that. Which remembers how Caroline knows very much how to not measure, but how to use tools to analyze systems and get and how fails could happen. I don't like very much the word human error. That's why I said fail. So and going that, could you take a sum of what we talked right now, Caroline, and say, in your opinion, how could we use the tools that we have here in academia or in business to help to improve the safety in workplaces?
Yes, of course. Well, first of all, again, don't be afraid of using human error. It's science. We fail under some conditions, as Valeria said, under some context. As a component fails sometimes. So the methods that we are showing you, that you can see some of them in the publication of HSE or in the human factors engineering, the good practices like API practices, things like that. They are going to show you how to improve the context, how to improve the system, so the human is not going to make those errors anymore, to avoid those errors, so to take this responsibility from them. Okay, so I think just use the tools that are there. Just use them in the project. I think first of all, you have to use them in the design phase, or the basic design and the other steps of design for production. You should use human reliability analysis and human factors engineering good practices to improve your design. And that the organization is making their part on reducing the probability of human errors. That's the point, what we can do for the organization to do their part.
Fantastic. It goes in a way, Caroline and others, that I can say that human factors, human reliability, and ergonomics are in a certain way totally integrated, because 2 points, in my opinion. First, the object of stud is the human element, not the human factor, not the human analysis, the human. And second, each one has methods. For instance, ergonomics, the ATC and ITC, human factors from start and stamp, human reliability, Crane, Atiana, and others. So, and I think that the difference is how to deliver it. So I believe that when the project finishes, and then you have the daily basis operation, I think human factors will go very well. And ergonomics is more related to design and other part, although there is the cognitive ergonomics very similar to human factors. And also it reminds something that there is, how can I say, in all cognitive systems in the world right now, this pandemic. It's for everyone. There is no such thing that wasn't affected in the world. So, as how can I say, not the last question, but almost closing question, with your expertise in your area, how was this pandemic affect, and how could be, from your side, from your perspective and opinion, solutions from your discipline to help to pass this very thoughtful moment? I think we can start Scrumble, maybe Felipe starting.
Okay, so I believe that all these pandemic situation speed up a lot the automation, right? We we see a lot of merchandising for drilling companies saying that they are doing parts of the drilling phase from the well, doing it autonomously or remotely. I mean, all these avoidance to bring people in the rig or in the offices could speed up some points, right? But on the other hand, I understand that the systems or the structure behind might not be evaluate so fast. So now that things are trying to get in a new normal, let's say like that, it's time for us to rethink and analyze it and see, okay, we put everybody to work from home and we are drilling on a well from home. Okay, so let's understand what is the implications behind. It's not why it could be done in the past and flawless or not, but I mean, happen. That will not have a big problem in the future. So let's understand what we did in a very fast way to make things walking, and study again, evaluate, test, redesign, rethink, and prepare for this new way.
Fantastic, Felipe. Thank you very much. It remembers the NASA annual technical report that was during 13 years, saying that it was impossible to reuse rockets to enter the atmosphere. And now, what did you got? So
Yeah.
we always find a way. And just not being so gentleman as before, let's ask Hector right now because he's about to leave. He has some responsibilities later. So, Hector, the stage is yours.
Yeah, how the pandemic affects safety in organizations? Very much. Remember, this is a new disease. There were a lot of things that we didn't knew about COVID. We are learning every day, right? New information, new stuff, vaccines. So there were employees that were never used to work from home. They didn't have the possibilities to set up a space to work from home. They were not used to connect 8 hours of their days working from home. Some of the employees like it. Some of them with limited resources were struggling to get the job done from home because sometimes the family thinks that the employee is on vacations or is 100% available from home, right? And we are not used to, at least in Mexico and in some companies, we were not used to work from home. So it was a completely change of game for a lot of employees, put a lot of stress. Employees were working from locations without an ergonomic analysis, for example. That is very much controlled inside sites and offices and everything, but from home, it changes the game, absolutely. We started working and talking more about PPE that we didn't expect to wear a mask at all times, right? So there were employees that could not breathe, that were suffering some other complications, lung complications that got worse wearing a mask all day. For example, some assembly operations here in Monterrey got the challenge of the social distancing in an assembly process. That was a real challenge. Maybe you're thinking more about the oil and gas industry, but there are automotive industry, electronic industry, medical industry, that in Monterrey, there are operations with 3,000 employees, 6,000 employees under a roof. That's a real challenge. So in that part, the HSE professional became more and more and more important, giving guidance. And the challenge for us as safety professionals, it was speeding up, stepping up with all the knowledge. We have to learn fast, make mistakes fast, and learn faster in order to deploy all the procedures, all the guidances from CDC, from the health authorities in the country, it has been a very, very big challenge for the safety professionals to keep up with all the developing of this situation, of the disease. But I think we are up to the task.
Fantastic. I have no doubt at all that we are up to the task. Although when you said about doing something faster to gain knowledge, remember the faster, better, and cheaper from NASA, that work not so well. So let have some, how can I say, knowledge from that as well. But we are up to the task. I have no
Yes.
doubt at all. And we also up to the task, answer this question. Caroline, please.
Well, I think it was Bettina has made the question about the pandemic, right?
Exactly. That's the
Uh,
one.
Yes, Bettina, perfectly. We are, as the regulator, the oil and gas regulator and safety regulator as well, our division, we are very concerned since the beginning with the minimum staff, because of course you might imagine that we are having those breaks. How do I say, Marília, in English, when there's a surto in a platform? I forgot the name.
Outbreak.
Outbreaks. Thanks, Josué. So we had some outbreaks in lots of platforms. So to minimize those risks, they started to have to say to the agency, to our agency, what was the minimum staff. Because they started to have minimum staff on board, but we wanted to know the minimum staff for safety. So I understand, Josué, you made the question about how people are feeling in the platform about that, but they might be very fatigued as well, mentally and physically fatigued because of those minimal staff situations. My concern was that most of the time, the minimum staff was not calculated or with a method. Okay, of course, they understand what are the critical procedures on board. They try to calculate on top of the number of critical procedures and we checked that. The team checked that those procedures, if they could be done. But actually, who has actually opened each critical procedure and used a safety critical task analysis, measuring time, measuring workload, and or use a human reliability analysis to know if that is the minimum staff of that platform? We have to improve that safety level so people are not going to get fatigued or make any human error due to this new context. So yes, that's the problem that we have. It's real, Bettina. You're totally right, and you can see those numbers of COVID disembarkment from platforms due to COVID in ANP website.
Fantastic, Caroline. When you were talking about the minimal staff, this minimal staff word in my mind kind of triggers something. And I remember Piper Alpha. I remember BP Texas City refinery. And I remember the two NASA's accident. Actually, in this book here from Diane Fong, there is this not exactly phrase, but there is something very similar with that. A minimal staff required, demanded, something like that. So I don't like what you said and these ideas of accident. Maybe we have to see it right now and try to solve. Maybe using one of the HRA tools that you mentioned. And once we are talking about this as well, I'd like to invite Marília, one of that specialists here, to talk about this COVID situation and closing our debate for this time.
Thank you, Josué. Thank you, the other three panelists, and you as well, Josué, for the great points raised about the impact of COVID and the understaffing, the work and distance, and how all of this, of course, impacts safety. I want to take actually something that Felipe said about how COVID situation has kind of speed up the automation of some plants. So I just want to take this perspective because I have been working with autonomous systems and especially autonomous vessels when I was working in Norway and autonomous cars here in the US. And sometimes when I say that I am a human reliability analysis specialist and I'm working with autonomous systems, people get, well, you're not really needed in that system, I guess. Let's call a software reliability person. But the fact is that actually it is a distribution of tasks, right? And it's something that human factors engineering has been dealing for so long in this human system interaction in highly automated systems. Of course, autonomous systems are different than highly automated systems because of the level of decisions and freedom that the systems have. But there is something interesting when we see all that, and like in the oil and gas, how we see the launching of uncrewed platforms or platforms that are going to be uncrewed for like most part of the year, and people will go only to do maintenance and all that. How we have to understand this new way of working, that it is because it is coming, of course, and it is coming fast. And what we can leverage from what we have in human factors engineering and human reliability analysis as disciplines to analyze possible errors in these operations. So for instance, on autonomous vessels, something that is planned is to have a control room on shore. And you would have, of course, a reduced staff that could be able to monitor the vessels and could be able to remote control them when it's necessary. Well, the nuclear industry works with a main control room for a long time where people are actually, okay, you are in local, so it is a bit different than being in distance. But you have all of this information that we can grab and adapt and analyze and use for this kind of analysis, like control room, onshore control room, or remote control rooms, also for platforms. So there was also another question I was checking on YouTube, someone that was saying how to prepare to be an HSE professional in these new times or something like this. And I would say, in my perspective, that understanding this new way of working, and especially working in distance and remote controlling and monitoring everything through a screen and not really going there, and this highly automated plants and systems, I think this is a great path to go into, because I think this will grow a lot, and we will see human error on that, because we have been seeing as the accidents that we have with autonomous cars. Sorry, my thing is falling. But as recent accidents that we have with autonomous cars, actually, the human that was the safety driver was to blame. Was blamed at the end by the investigation. So we can discuss that in different perspectives.
I believe, Marilia, we would like to have a full and live like this just to talk about accident and this blaming and how can I say system that we have since 1931, when Heinrich said that it probably was to unsafe acts from humans. Well, I believe you guys cover practically 100%, in my opinion, 100% of the question, and I have nothing to say regarding this. But I would like to have a quote from Yuval Noah Harari on his last book, Notes from Pandemic. Whatever this pandemic showed us that whatever comes for human nature, always we will have the worst and the best. And I really enjoy, and it's a very reflexive quote from Yuval Noah Harari in his last book. And talk about last things. I think we are in the time for our last round, but this last round I would like to be something different. Instead of answering question, you have a time to say something, a phrase, a word, a kiss, anything. And once Hector is about the time to go, I think Hector would be the first, our international, together with
Thank
Marita,
you.
participation here.
Oh, thank you. I just want to say thank you to SPE for the invitation. I had a great time. I recognize a lot of fantastic professionals here in the panel. I really appreciate the opportunity to share my thoughts with you and appreciate your invitation. Fortunately, I need to drop in about 3 minutes, but I will stay to hear the rest of you. Thank you so much for your invitation.
Thank you, Hector. Your participation was great. Thank you very much. And then doing some scramble, maybe another international participation, Marilia.
Thank you, Josué, directly from Recife, Pernambuco to Los Angeles.
Yeah.
So I want to thank all of you. I want to thank SPA for the invitation. It was really a pleasure to be here, and thank all the panelists. I learned so much in this panels. Of course, I learned from the questions that the audience had, and I learned from the other panelists. It is always sad when it finishes because it's so short. I also saw that there was a lot of questions on YouTube that, of course, we do not have time to respond. So I want to invite everyone that has any question on HRA or anything related to it. Please feel free to send me an email at marilia.ramos@ucla.edu. I'm going to write it down in the YouTube comments. It's going to be easier. So please feel free to send me an email, and I can respond to them by email. And thank you all.
Thank you, Marilia. My wife is from Northwest as well of Brazil, and I really enjoy this part, not only the sunshine, but this warm welcome that people from there have. So fantastic.
Yeah.
Thank you very much. And then Felipe, please.
Okay, before I do this, I will make a joke with you, Josué.
Yes.
You know that Amazon is selling background pictures for us to do our presentation.
Yeah, I bought mine.
And yeah, you proved today that's not from Amazon. You pick a
Yeah,
book and show for everybody.
Amazon.
It's not from Amazon. I have a book. Well done, well done.
All right.
Okay, guys, thank you very much for the invitation. It was a pleasure to me to be here talking with all of you, trying to answer as much as we could, right? And please, I will also drop my email on the chat. And if anybody has any other question or any other comments, whatever, please feel free to send me an email, and we can keep talking about this topic, which is amazing and very, very charming.
Thank you, Felipe. Your thoughts and insights was amazing here in this panel. Thank you very much indeed. And closing our last calls, last phrase, last message, Caroline, please.
Thank you, Josué. Well, my last message is kind of trying to respond Jaleel as well. He asked about the regulation. If our offshore oil and gas safety regulation, he knows it's being updated. He's asking if we are going to update something about human factors, the management practice on human factors. Yes, Jaleel, we are drafting it. We are trying to make it more clear about human factors engineering, about human reliability analysis, about safety critical task analysis, because it's there. We understand that today is there, but people don't understand that. So we really want, of course, we don't know if this will pass. It's going to be for the audience and the industry to give their opinion on that, to see if they are prepared. But I would like the last message, in fact, is that when it comes to human factors, there's lots of opinion. There's from anyone, because we are humans. We think that we have to have an opinion about human factor, and we think we know about human factor. But there are lots of science. There's lots of data. So I know we are in a world that we sometimes can't understand the difference between opinion and data. But ANP, the regulator, is looking for the data, for the science, what's proved there, out there. We are not looking for really different and new things to happen in a platform. We just want basics, something that is going right on other countries, and it's written in procedures, and it's approved by databases. So we are going this direction. We are not making anything up. That's the message. We just want safety, and we don't think that human factor is the best new thing in the world, because we know there are lots of other things, safety critical systems and components that and management of changes that we still have to improve in industry. So human factors is one of them, and it's transversal. It's not the most important of them. Thank you.
All right. So I think we are in time to finish our. Oh no, I forgot myself. Oh, sorry. Yeah, I got failed. Yes, I have one last message for all of you who is here at CISN, and the speakers, and of course ASP. I think I never said this phrase before. People, worker, are not the problem, they are the solution. That's the message. I never said that before. So I would like to invite João to come and join us and finish this great moment here. João.
Exactly like I said in the beginning, not too much to say after that, after your words. It's really nice for us to see. We extremely appreciate to see that after 10 HSE talks in a sequence, we are now becoming heavier and heavier and heavier when joining skills like yours. So many thanks for bringing us, although we can see in Marilla's eyes, for example, and in your the eyes of sadness by not having more time to discuss and to address the huge knowledge that you have been capturing along your years of study. But we do not have at that time now, but we have, and now much more. We have the interest, the idea, the project. I'm sure that everybody who have attending this session is now much more focused on getting more knowledge, on going deeper on human factors, human reliability, cognitive systems, and you deserve all of our thanks by helping us on sharing knowledge, the essential mission, the core mission of SPE, and bringing such amount of knowledge to motivate our people to have us moving ahead with safety here. I would like to share, if João Pedro can do that, and Itamar, share some emails, like Marilla said, because I have a bit different position than Marilla with regards a young student. How could he or she become a stronger professional in terms of HSE in the field? Probably based on my white hair, I don't know, but I would like to also recommend this person about some visits to the plant, some visits to the process, to see where we have the technology side of the risks. But anyway, it's a very long discussion, and so we invite all of our participants to send your notes, to send your messages, exactly like Marilla said. We will reply you and share a bit more about our own experiences with you. Tito Weber, it's your question. So please send us a note to Marilla, to myself, to João Pedro, to Itamar. We will be in touch with you to share a bit more. And please let us all be joined together in the next month discussing about material fields, but with this feeling, this strong feeling that you lecturers brought to us today about human behavior and how we should support our human being. Yeah. Thanks a lot to all. Itamar.
Okay, thanks, João. So I'm very glad. I'm very happy about this session today. So it was excellent. So yes. So it was a kind of a great birthday gift. So thanks for all your panelists. So you are really high skilled. So I'm very, 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 very happy with it. So, and thanks for the really consistent audience we had today. So I just want to thank for everything. So, and say bye. So join us. Keep watching all the things we're doing at SPE. So thanks a lot. Good evening.
Boa noite.
Thank you. Boa noite.